Okay, we'll deal with more numbers, but rather we'll have a quick introduction with inbuilt functions. Okay, so we'll be seeing more on Python numbers. A quick recap: in the computer world, numbers are numbers that you can add, subtract, multiply, and divide. Whereas Python also differentiates whole numbers like integers and also numbers that contains decimal points, that is floats, and also words, that is textual information like names and address, which are stored as strings, which is in short for a string of characters. So basically, a single character having multiple characters joined together is a string. So in addition to numbers and strings, there is a boolean also. So these are the data types which we had seen earlier. So again, boolean can be true or false, or it cannot be nothing anything else. So it can be either true or it can be either false. Only two conditions. So in real life, we dealt with something like dates and times also. Okay, so which is another type of information, but Python does not actually have any inbuilt data types for date and times. Okay, so there are but thankfully there are a free module which can import anytime, works with such information. Okay, so it can be like if you're looking for time based on your local region, or using green time Mediterranean GTM, or if you want to differentiate between the AM PM. Okay, so even those will work. So again, if you're interested, you can go ahead and check that. So now we'll have a very quick basic introduction with respect to functions, which can work out with mathematical operations. Okay, so that is calculating with numbers. So usually functions will be something like this with respect to the general syntax for the inbuilt functions or any other functions which you are using will be having a variable name. So this will be the variable where end result is saved. So if at all you don't want to save the end result and correctly get the answers, so even that can be like you don't need to save it. Example in Python shell, which we usually don't save the answers, rather we'll be seeing the result in the real time. So you can do that also, but this is a general syntax. It is always best to save the result and use it elsewhere in that condition. So basically most functions return some value. So you typically start defining a variable to start to store what the function returns, and follow that we'll have an equal to sign. Okay, and then we'll have the function name, and within function name will be like followed by the function name, no spaces, we'll have a parenthesis. So parenthesis are nothing but a common bracket, or square parenthesis, square brackets. Instead of brackets, we will be using parenthesis, the keyword. So inside the parenthesis, you can pass many parameters. Okay, so here you have parameter, and again inside that you can pass something like arguments also. Okay, parameters or arguments, so both are same to the function. So for example, we'll be seeing absolute value. So if you are familiar like with a math nerd and all, you know what is an absolute value, but still need not to worry. So here absolute value will take a number, and which will give out an absolute value of the number. So this means if you pass a negative number, it will give back you a positive number. If you pass a positive number, it will send back positive number itself. So basically it will remove the negative sign. Okay, so that is about absolute value. Again, we'll be seeing we'll be working on absolute value, and also we have few more conversions. So if at all you are familiar with number systems, if you are not, do go and learn about number systems, very basic concept. So you have four types of number systems. So we have base 2, which is binary, which will have either 0 or 1, and base 8. So basically let me just show you over here. So system is base 2, which is called as binary. It has only two digits, so 0 and 1. So these are the two symbols which are used. So representation is like 0 small b. Okay, so 0 in binary, small b for binary, and you can convert any decimal number into base number by using bin. Okay, bin converts into binary number. Okay, so and next is octal. So octal will have 0 to 7. So those are 8 numbers. So oct is the command which you will be using to convert into any octal functions. And we have base 16s, which are kind of widely used. Okay, so that is hexadecimal or hex. So here we will be having numbers from 0 to 9 followed by A to F. Okay, so, these are the 6 alphabets which you are using. Again, it can be big, it is not exactly case sensitive. You can use small alphabet also. You can use big alphabet also. But here you will represent with 0x for hex. Okay. So again, conversion can be done using a hex command. So similar to this, you can convert a normal regular number into a float. You can convert. You can actually format it in a different way. So there is something known as a f string, and also you can convert a float into integer. You can find out maximum value between numbers, minimum value between numbers, rounding off, strings, type, which we already saw. Okay, so we'll see those now with respect to editor. So we'll just go back to our spider. Okay, so now we'll just try to use apps itself. So maybe I don't need this, so we'll work on the console itself. So let me just make the console a bigger one. Okay, so I hope now we can do. So let me as I was telling, we'll start off with apps itself, APS, followed by open bracket. Here you need to give, so returns the absolute value of the argument. So basically if I'm using 3, it will return 3 back. So apps of 3.0, let us pass float, it will return back float. But what if I pass minus 3.0? It is giving me 3.0 itself. So I was telling absolute value is nothing but the actual value ignoring the sign of it. So it can be positive sign or it can be negative sign. So basically here you can send a positive 3.0, which will give me 3.0 itself. Okay. So this sign usually for positive we don't mention it. So if it is unmentioned, so it is taken as positive itself. Okay. So even we assume in the same way. That's how even Python is created. Okay, when you don't need to mention the sign if at all your value is positive. So that is it. So binary numbers. So if you are not familiar, binary of 3 is nothing but 1 1. Okay, so let me just calculate that. So bin of 3. So that will give me 0b. So it is telling I'm having a binary number. So value of that binary number is 1 and 1. Okay. Again, binary number of 3 in octal is nothing but octal itself. Sorry, not binary number. The number of 3 in octal is octal itself. So let me just go ahead and check that. Oct of 3. So it will give me 0 O for oct and 3 itself. But in octal I have to 0 to 7 itself. So what will be my 8 in octal? It will be 1 0. So that is what it is printing. Okay, 1 0. So successfully it is converting. And what about hexadecimal? The hexadecimal comes until 15. So let me just check with 10. So this numbers whatever I'm inserting inside is a decimal number. Okay, so I was telling 4 decimal systems, right? Binary, octal, hexadecimal, and the other number system which we have adapted right from our early age. So that is the number decimal number system. Okay, so octal 10 is represented as A, 11 as B. Okay, you can check that. 12 as C, 13 as D, 14 as E, and 15 as F. Okay, after that it will increment to 1 0. Okay, so that is like 10 in decimal. Okay, hexadecimal of 16. So if 16 is 0x10, so that is converting. So again few more data types. So let me try converting a integer into float. So float of 3, so it will give me 3.0. 3.0 is nothing but a float. What about integer, the reverse way? Int of 3.0, so it will give me the integer value. What if I have 3.9? It will give me the only the integer part, which is 3. And to round off, we have a command known as round. Okay, so you can try that round. Okay, let me just type correctly. 3.9. So here it is giving me 4. It is rounding off to the nearest decimal place. Okay. So basically this will round the numbers into nearest decimal place. It may not be in one number. It can be 1.0 also. Something like that. Okay. It is okay. Single numbers. Okay. What about 3.8? Still 4. 3.6. Still 4. 3.5. Still 4. What about 3.50? Obviously 4. It is the same number. What about 3.4? It's 3. 3.49. It is 3.3 itself. So basically anything above equal to or greater than 0.5, it will be rounded to the next number. Or if it is lesser than the lesser than 0.5, then it will be rounded to the lower number. Okay, and also I was telling there is a command known as max. So max of 1 comma 2 comma 3, so obviously 3 is the maximum number, it is returning 3. So what about minimum value? Okay, so 1 is the minimum value. So where exactly you can use this max value, minimum value? Maybe you have marks of students, okay, or maybe I'll give an example of cost of groceries. I think that is a better example. So cost of groceries over there, you wanna check out which grocery has the highest unit price. Okay, so you can just send max of groceries. Okay, one single this one you can declare in a list, which we'll be seeing later. What are lists and all? List tuples. So those are like arrays of elements which we'll be seeing, and also we have already familiar with type. So type of true, which is a boolean, right? So type, and a few more which you can remember is maybe we'll see square root. So do we have a square root? Sqrt of 9? No, it doesn't has. But the inbuilt function like has only a few in handy. But like square root over here, there is still a lot of other which can be done by importing something known as a math module. Okay, so how exactly we will be importing? We'll be using the keyword import. Again, I'm telling this as a keyword. You can see it is turning into purple. So even this true was turning into purple. Again, we will be coming across a lot of keywords. So true, false, and import is the other keyword. So we'll import math. So let me just save this as sqrt square root of pi. Okay, so square root of pi. I'm importing math. Okay, so now can I use print square root? So I have imported already this math, right? So it has a function square root. You can just go ahead and check that. So it has a square root. So let me just get square root of maybe a number like 49. Okay, so let me just save this, execute. It is telling an error, still telling square root is not visible. This square root is present inside the math module. So basically we can't just directly tell it is square root. So where exactly it is? It is inside the math module. So math dot square root. So here again math module has a lot of functions. So factorial, fabs, exponential, I guess, pmod, floor. Again, floor we were seeing later, right? Floor divisions. GCD is close, is finite, logarithmic, power of. So you can see lot and lot are there, and also here there is some kind of keywords which are declared. So these are keywords which are with respect to math itself, but it is not with respect to us. Again, these are arithmetic error, aggression error. So here we have name error, right? So name error is a keyword. You can't declare a name error as a variable. Okay, I think we can declare. Okay, name error is getting declared. Okay, which was not possible earlier. So this is obviously an syntax error. We can't use this one. Okay, so name error. So these kind of errors will be declared with respect to our math. Okay, so if at all your text editor might not be showing. So let me just run this, save this first and run it. So here it is telling us 7.0 and it is giving me and float values. So basically if I give 48, it will evaluate for that also. It is 6.92820. Okay, so it is doing like this. So maybe I want to round off that. So I can use another function over here, round math square root of 48. Okay, so let me just save that, run. So here you can see it is giving me 7. So it is rounding off to the nearest value. So that's why I was telling Python is kind of a textual language. So directly it is like print rounded off value of math of square root. Okay, like square root which is present in math. So if you want this documentation, let me just launch Google. So math Python. So you can run that, and here you will get the documentation. So docs.python.org. So over there you can find. So math seal and what exactly it is returning the ceiling of x. Okay. So copy sign, it is copying the sign itself, only the sign. Like here it is copying the sign from minus this to this. So it is taking the sign over here and giving it over here. Fabs is nothing but again absolute value. We are not using apps because apps is already declared. Okay, so that's why it is using fabs. So again, when you're importing multiple models, it should not have different methods. So that's why math.extension is used. If you wanna, if you don't wanna use this, it is better to import math and do that. Else, what you can do is uh, from math import star. Star means everything, or you can import sqrt, one single one. Okay, one single function, and now you don't need to declare as math dot. So here you are not declaring everything, you're just importing square root, not everything. So let me just run that. See, it still works. So basically here you have imported only square root, and if you are trying to run any other function from math, it's not gonna work. Okay, so if you want to import everything, you can usually use a star. Okay, star says that you are importing everything. So let me just save that, run that again. You can see it is working perfectly fine. So now you don't need to use math dot when you are doing this from import. So basically this import from math import everything is like declaring over here itself. Local variable is declared. Okay, so that's how you can use the import functions. So basically we saw another keyword over here from. Okay, so another keyword is present over here. So later on in the course we'll be seeing a lot of other keywords. Okay, so for example we have many keywords like lambda. We can't use return, so return. Okay, it is case sensitive, so it should be smaller. Okay, return, we will be seeing return in functions. So those are the few keywords. Again, we'll be seeing everything one by one. And also with respect to documentation, you can find all the operations of the math module. Okay, similar, this is the kind of declared from Python itself. Like the creators of Python has created this math library. There is a lot of open source libraries which will be again working on in the few further in the course, and those libraries, even you in the future can create a library for one particular operations. So the libraries are very powerful tool. You don't need to write again, create something like square root. You might need to create a function to find a square root. You can use guess and check algorithm. Basically guess and check, if you want to find out the square root of 48, guess a number. 6 are definitely not 48, that is 36. So it is greater than, you go to 7. So 7 sevens are 49, it is not 48. So it is less than, it is between 6 and 7, a fraction part. So your computer can do millions of operations, okay, in a second. So the computer is very quick. Okay, so even if you have for example you have a switch which will turn on a LED, before you turn on the LED, your computer will be doing 10 operations. Okay, so basically this is an operation, this is an operation, so it will run a lot of operations within a second. So even if it can perform so many operations, we have to be smart with respect to our coding. Okay, so that's all for this video. So again, in the going further in the new videos, we'll be learning more about the Python.